In this video, I'm going to use FullChip to play around with this layout. This is an SRAM layout that I generated with an open SRAM, and it's for the SkyWater 130 process, but to make it more interesting, I reduced the scale. So in FullChip, you can set the scale, and here I've chosen to be 0.5. And so feature sizes are on the order of 75 nanometer features. Okay, so we're going to focus on just one layer. So I'll show that layer only. This is a poly layer, I think. And we're going to look at different regions. I just picked 3 regions, and then a real small one we can just test around with. I've defined a few litho models here. This one is a 248 litho model, chrome on glass, and this is a 193 litho model. And this is the same litho model, but it's through focus. And so I have TCCs loaded at different focus values, and they are indexed by this defocus variable. I'll show you how to use that later. Okay, so those are the litho models. Here's the ops. So the first op is an SRAM placement. So I can run that on the current region here, which is just this little red rectangle. And let's look at let's show input-output layers. So you can see it did OPC. That's the cyan. So I'll turn off the SRAMs for a moment. That's the aerial image. That's the OPC contour. And this is the target, which was the layer we're interested in. So now let's run a verification. We're going to simulate this and see if we're going to look for errors. So in the verify op, we've chosen the output of the OPC. We've got the assist layer, and we're going to put our outputs here on 66202. Okay, so we'll run this. Okay, and so the way this works, the verification, is you choose your layers and some other properties. We choose our litho model. In this case, I chose the 193 litho model. And this is the metrology setup. Okay, there's a help page here that explains these parameters. But basically, these 2 parameters look for pinching and necking, or pinching and bridging. I guess the help page will show you that. So this is bridging and this is pinching. And the next parameter, this is the target layer, which is when you want to compare the aerial image to the target layer. And you can either do contour-based EPE, edge placement error, or you can do point-based. In the point-based, points are added. These are test points at which the edge is detected and seeing how far the edge is from the target. These parameters control the tolerances and when an edge is considered a jog, or when an edge is considered a line end, and the spacing of the test points. So here you can output the test points to a debug layer, and that's what these little gray tick marks are. Those are showing the test points. You don't have to output that. Just put a negative here and you won't see it. So the hot spot output layer is 203. So we could say find 66203. It doesn't even exist, so there's no hotspots there. Okay, the other thing is we can do this through focus. So let's go back to the litho model. This litho model has 5 different sets of TCCs, and they're all indexed by this variable name called defocus. So in the op, on the litho model, you can specify different focus values. So you could say defocus equals 0 and 75. Well, sorry, 0 and 50 and 100. Okay, and if I run those, so here are the three contours. This is defocus 0, this is defocus 0, defocus 50, and defocus 100. One feature that we have is interpolation. Even though our TCCs are discrete at -100, -50, 0, 50, and 100, we can also interpolate and run a value that we haven't TCCs for. Okay, and so now this is 0, 50, 75, and 100. Okay, so now when you have multiple layers like that, it's going to go and look for errors, and it's found a whole bunch of errors. So let's hide the debug layer. And so all of these red points are hotspots. It's error because the defocus of 100 is killing us. So if we just do defocus 0, we're not going to find any hotspots. So let's do 75. Okay, now we have a red point. So let's find 66, 450. So we have at 75 defocus, we have a few different red points. It looks like the line ends. So we have 15 red points just in this area. Now, of course, we can do all of this for a large area or larger areas. So in this case, if I zoom out to the full chip by right-clicking and I look at my regions here, I've got these three regions and they all have a group test. We can do these operations on all of these regions. Here, I have three regions all with the group test. So I'm gonna choose the group name. These ops are organized in groups. This is the op group. And I'm going to run on a group test. And so if I say show input output layers, you'll see that that one ran really fast, adding the SRAFs. And now it's on to the OPC. And there's 217 tiles, and I'm using 3 machines, and the 3 machines have, one machine has 32 workers, and the other 2 machines have 16 workers, so 64 workers total. So the 64 workers are working on 217 tiles, and if we look at the layers here, we can see them popping in as they're finished. So the OPC and the aerial image contour are popping in. So this is real time. So these litho models are fast litho models. They're not the rigorous litho models, but we also have the ability to do this on using Hyperlith's rigorous litho models. Okay, this is almost done. We're at 198 out of 217 tiles done. Okay, that's the OPC, but it's going to run the verify. So let's show those layers. So that runs really quick, much faster than the OPC. And then finally, it's going to run. Okay, the TCCs are there, and you can see that it's running fairly quickly. All right, so let's show input-output layers only. And of course, we need to look for these red points. Okay, there's a red point. So we can use find 6450 on the full chip. and the search results appear up here. So we found 2,000 hot points. Most of them are, so there's 3 right there. And so if you just use the arrow, you can review these hot points, and they're probably all the same. Now here's an edge hot point. Well, there's a whole bunch of edge hot points too. Okay, so let me show you something else you can do with the verify. So let me close these results, and we'll look at this verify op, and we're going to do defocus -75, 0, +75, and dose equals 0.9 and 1.1. Okay, and so instead of generating contours for each of those possibilities, we're going to generate a PV band. Okay, let's get to our current region and just run it here. Okay, and so now we have a PV band, this yellow PV band. Okay, so we have this yellow PV band, and we can see that the defocus and dose cause a variation in PV band. And the thickness of the PV band says how much the aerial image contour or the aerial image edge is moving as focus and dose vary. And of course, we can run that on the we can run that on the test region. Run group test. And again, using our parallel processing, it's running with 3 machines, 64 workers, 64 PSSs, and 217 tiles. Here you can see that the scatter bar is printing, and we can detect that too. This currently, when we output PV bands, we don't have metrology on PV bands, but we will soon add that so that you'll be able to flag places where the PV band is thicker than you want it to be.